All right, so I'm going to go through the odds on this 25 review. So if you haven't done the odds, you can follow along and get the odds done, and then you can go back and do the evens to submit. So I'm going to go through these questions, but I'm going to go in the order that we've been trying to work in. Step 1 is to find the y-intercept. So to find the y-intercept, you're going to plug in 0 for x. So if I plug in 0, I get 0 divided by 6, which is 0. So I plugged in 0 for x and I got 0 as my output for y. So step 2 is to look at your x-intercepts. And the shortcut that we learned is you're going to set your numerator equal to 0 and then solve for x. So in this case, my numerator is 5x, and when I set that equal to 0, to solve for x, I would divide by 5 on both sides, and look at that, I get 0. So it should be no surprise that our x and our y-intercepts both come out to 0, 0, but we achieved the outcomes different ways. We plugged in 0 for x to start for y, and then to find our x-intercept, we set our numerator equal to 0 and solved for x. So it's important to know those two processes. So then we're going to look for step 3 is find our vertical asymptote. That is when you set your denominator equal to 0 and solve for x. So in this case, x plus 6 gets set equal to 0. And when I subtract 6 to the other side, I get the vertical asymptote at negative 6. So I write intercepts as coordinates, 0, 0. I write asymptotes as equations. Vertical asymptote x equals negative 6. So then step 4 is to find the horizontal or slant asymptote. So to do that, you compare the power of the numerator and denominator. So in this case, they're both linear functions, x to the first, x to the first. So they are equal in power. So when they are equal powers in the numerator and the denominator, you strip the coefficients of x. So in this case, I have 5x over 1x. So the coefficients 5 divided by 1 is 5. So this is going to have a horizontal line asymptote at y equals 5. So I'm going to skip example 2, so I'm going to leave these questions for you. However, I want to help you factor this because if factoring is the problem, you can't answer these questions. So if we factor out a greatest common factor in the numerator, I would factor out x squared, and I'm left with x minus 4. So that will help you when you're finding your x-intercepts. And then the denominator, using the diamond method, I'm looking for the factors of 2 that add up to 3. So that would be 1 times 2. So x plus 1 times x plus 2 is my denominator. That will help you find those vertical asymptotes. So you should be able to answer example 2 if you haven't yet. So I'm going to go on to example 3 and lead you through these questions for this next odd function. So on this function, I like to start step 1 finding the y-intercept. And so if I plug in 0 for these x's, I get 8/24, and 8 over 24 is 1/3. So when I plugged in 0, I got 1/3 as my y-intercept. So kind of my step 2 is finding the x-intercepts. Will 8 ever equal 0? So if I set the numerator equal to 0, will 8 ever equal 0? No, it can never equal 0. So there are none. There's no x-intercepts. Step 3, I like to look at my vertical asymptotes next. When will the denominator equal 0? It would be helpful if we could factor this. So we are looking diamond method, the factors of 24 that add up to negative 10. So that would be negative 6 times negative 4, x minus 6 times x minus 4. If I factored the denominator, I know that my two vertical asymptotes are going to be at positive 6 and at positive 4. X equals 6 and x equals 4. So let's put those on our graph, because I can still do that part without looking at a calculator. I'm going to need a calculator to help me with all these different regions of the graph in a minute. So step 4, the horizontal or slant asymptote, this time the denominator is a bigger power for x. And so if the denominator is a bigger power, the asymptote is always y equals 0, because when I plug in a really big number down here, like 100, and I square it, 8 divided by a really big number is going to be a small number, like 0.000001. So I have an asymptote at y equals 0, which is probably why I had no x-intercept. So I know that this part of the graph must go up like this elbow, but I'm not sure what's going on over here. And so at this point, we could look at the graphing calculator as long as we know how to plug it into the y equals menu with the correct parentheses. So there's my left region that I've already graphed. So what's happening is there's actually a region way down here. It looks like at 1, 2, 3, 4, maybe at 5. It's down here at -7 or -8. And so on my graph, I can kind of draw that going downward part. And then over here, it looks like the region is in this section of the graph. And if I wanted to find an exact point, I could plug in a value like 7 for x, because 7 is to the right of that asymptote 6. So when I plug in 7, what do I get? I get 7 squared, oops, in the denominator, 7 squared minus 10 times 7 is 70 plus 24. I get 8 divided by 3. So 8 divided by 3 is what? Right up here, 2 and 2/3, I think it is. So if you want to find exact values, you can. So now find the domain of the function. When I skim from left to right, where do I have my undefined x values? So the domain would be all real numbers except x cannot equal 6 or 4. And then I've graphed the function. Number 4, you're going to have to try number 4 on your own, and you will be factoring. And actually, do I ask you about the whole? Yeah. Let's do 4a together and find the coordinate of the whole, in case some of you had trouble on that part. So when I factor the numerator, I factor out a greatest common factor of 2, and that will leave me with x plus 1. And then we've already factored this once on the front page. It's x plus 1 times x plus 2. Well, what do you notice that's the same in the numerator and the denominator? This factor of x plus 1. So really, the function that we want to focus on is 2 over x plus 2. So you are going to answer all of these questions about 2 over x plus 2. But now I want to find the coordinate of the whole that's somewhere on this graph. What was this function originally undefined at? It was originally undefined at -1 in the denominator. So my whole is going to be at that same x value, -1, where this was undefined. So if x is -1, what will y be when I plug it back in? I'll get 2 over 1, right? Because -1 plus 2 is 1. So 2 over 1 is 2. So that tells me when I'm graphing this, right at that point, there's going to be a hole in the graph. And so my graph might go through it like this. You know, I have to answer these other questions to figure out what the rest of the graph looks like. But at least now you've figured out where that hole is. So you're going to finish number 4 if you haven't for the evens. All right, so number 1. I wanted to make sure I did one that has a, none of these have slant asymptotes. So that's all right. We'll have to practice that on a different page. All right, so this is the next page of 25. So I'm going to make a list for myself. I'm going to find the y-intercept, the x-intercept, the vertical asymptote, and the horizontal or slant asymptote. So remember, to find the y-intercept, you're plugging in 0 for all of the x's. So you get 0 over -1, which is 0. And then for the x-intercept, you're setting the numerator equal to 0, right? So when you divide by 2, x is 0. So x and y-intercept both at 0, 0. My vertical asymptote, I'm going to look at the denominator where that is undefined. So it would be helpful if I wrote it in factored form for difference of squares, x plus 1, x minus 1. So my vertical asymptotes are at -1 and +1 because that makes the denominator undefined. All right, and then my horizontal asymptote this time, the denominator wins the competition, linear over a quadratic. Quadratic is bigger. So when the denominator blows up and gets really big, your asymptote is going to be at y equals 0. Now, if you notice something, you have an x-intercept that's sitting on that asymptote. So sometimes in one region of the graph, it will behave asymptotically, but in the other region of the graph, it might cut through the x-axis. So we've plotted our information. Let's take a look at a graph of this function so that we can finish here. So there's the elbow down in this region of the graph. And then we've got kind of this snakes right through the x-axis. And then up here, we've got this elbow in that top region. And I could plug in some points, like if I wanted to plug in +2, if I plugged in +2, I'd get what? 4 over 2 squared is 4 minus 1 is 3. So 4/3. So at 2, I'm right there at 4/3. 2 comma 4/3. So you can plug in x values and find y values if you don't have a graphing calculator. All right, so you're going to do example 2 if you haven't. All right, so example 3 is a good one for us to look at together. So y-intercept, x-intercept, vertical, and then horizontal or slant. So for my y-intercept, I'm going to plug in 0 for x. When I plug in 0, I get -9. So my y-intercept is at 0, -9. My x-intercept, I want to look at the numerator, and so I can actually factor that into the difference of squares, x plus 3, x minus 3. So I actually have two different x-intercepts. One of them is at -3, and one of them is at +3. Now my vertical asymptotes, I cannot factor the denominator here. And if I were to try to set it equal to 0, I would actually be taking the square root of a negative number because I would subtract 1, divide by 2, that would give me -1/2, and then take the square root of both sides. So I can't take the square root of a negative number. So that one would just be, there is no vertical asymptote. And for my horizontal or slant asymptote, they're both quadratic functions. I've got 1x squared over 2x squared. So my asymptote is going to approach 1/2. And that is a horizontal line at 1/2. So I'm not exactly sure what this graph looks like because it doesn't have any vertical asymptotes. So this would be probably too tricky of a one for you to graph by hand. So let's take a look at the graphing calculator, what this actually looks like. So it is an odd V-shaped graph, and it kind of goes here. Oh, I forgot to plot my 1, 2. There's -3 and 3. I forgot to plot my x-intercepts. So it kind of comes down through the x-intercepts, kind of makes a steep parabola, and then comes back up and behaves asymptotically here. And then there's that steep kind of a V-shaped parabola. I guess because of this squared, it's staying positive. And then it's just negative when x, when this comes out smaller than 9. All right, and you're going to try number 4. I'm wondering if number 4 has a hole that I might need to help you with. Let's see, this would factor into x minus 2 and x minus 3. And what are the factors of the denominator? X minus 1 times x minus 3. So this does have a whole, and when you start answering these questions, x minus 2 over x minus 1 is the function of interest, but you are going to have a whole at 3 comma something, because this function was undefined at 3, but we just canceled all that out. So we're going to plug 3 in over here. 3 minus 2 gives me 1 in the numerator. 3 minus 1 gives me 2 in the denominator. So it looks like at 3 comma 1/2, there's a hole on this graph. So you need to go through and finish the rest of example 4. And let's see, just example 5 is our last odd, it looks like. So let's go through those same steps: y-intercept, x-intercept, vertical, and then horizontal or slant. So for my y-intercept, I'm going to plug in 0. I get -4 divided by 0, which is undefined, so it has no y-intercept. For my x-intercept, I'm looking at the numerator. That will equal 0 when x is +4. My vertical asymptote, x times x minus 3. That's how I factor the denominator. So my two vertical asymptotes are at x equals 0 and at x equals 3. So there's x equals 0, 1, 2, 3, and there's x equals 3. And then for my horizontal asymptote, again, the denominator has a bigger power, x squared. So y equals 0. And then again, I've got this weird thing happening. I've got an intercept on my asymptote with 3 different regions. So feel free to take a look at a graphing calculator for a complicated graph of a rational function. Squared minus 3x. And make sure you put your numerator and denominator in parentheses to actually get it to graph correctly. So I put parentheses around each part. So this part is kind of down here in this region, and then I have this weird kind of parabola, and then this part of the graph actually cuts through and then goes a little bit positive on this side. It cuts through right there. So I wouldn't expect you to be able to graph that by hand, but answering these questions and then looking at the graph would be what you would need to do. So you're going to go back and finish the evens if you have not.